Hello, kittens. Today we have another one of the fundamental topics. Let's talk about Boolean values. Mastering this topic, you can confidently call yourself a great programmer who has grasped the truth. Let's open the file from the previous lesson, save it again in the same place with a new name. Let's call it Boolean. Create a new logical branch with the same name. In the scene properties, add the new branch to the list and disable the strings branch with a checkbox. It will still be attached to the scene but will be inactive. Just so you know about this possibility. So, briefly about the main thing. In essence, there are only two options for Boolean values. It's either true or false. For example, here's a simple expression with a Boolean value. After initialization, let's connect a setter. Give the variable a name, node is cool, and assign it the Boolean value, true. To do this, check the Boolean field. Next, when the space key is pressed, we'll request the content of the node is cool variable and print it to the console. Of course, we'll get true. If you uncheck it, it will mean that the variable stores the value false. And on this simple scheme, all logical operations are built. For working with numbers, we use mathematical operators. I hope you haven't forgotten that. Well, for working with Boolean values, we use logical operators. The result of an expression composed of Boolean values and Boolean operators will always be another Boolean value, either true or false. The three main Boolean operators are and, or, and not. Let's get to know them better. The AND operator is used when you need to check two Boolean values and determine if both of them are true. Let's create a simple scheme for clarity. We'll take a gate block. Connect the space key to the input and connect two Boolean values true to inputs 1 and 2. Choose the logical operator and pressing the space key will check both inputs for the true value. If both inputs are true, then the output true will be activated, and the code chain connected to this output will be executed. If one of the values at the inputs is false, then the false output will be activated, and an alternative code chain connected to this output will be executed. A practical example. Before going to school, you want to make sure you have taken a shower and grabbed your backpack. If both of these conditions are true, meaning they are both true, then you can go to school. But if at least one is false, in other words, equals false, it means you are not ready yet. To better understand the scheme, let's implement this simple example in our scene. Let's disconnect this logical branch from the scene and then link it to all three objects. Go to the properties of each object. Select the objects one by one and add a logical branch with the name Boolean. Now, for each object, add two variables. When creating them, choose the Boolean type. The names should be the same for all three objects. Let's name them shower and backpack. For the first object, assign the value true to both variables. For the second object, check one box for the shower variable. And for the third object, check one box for the backpack variable. Now let's experiment with the code. Remove everything unnecessary. Only those who have taken a shower and grabbed a backpack should go to school. Therefore, we need to getters with the names of both variables. The object fields should remain empty. This will mean that we will refer to the owner of the logical branch, so each object will check its personal variables. The gate block should have the logical operator and. To see the result of this check, let's add a translate object block from the transform group and connect it to the true channel. This block moves the selected object in the specified direction for the specified distance. The three input fields correspond to the three axes, x, y, z. Let's enter 0.2 in the y-axis. So, when the space key is pressed, if the character has taken a shower and has a backpack in hand, the object will take a step forward. If one of the conditions is not met, nothing will happen. Now, if we run the game and press the space key, we will see the sphere moving forward while the other objects remain in place. For a complete picture, let's also use the false output. Let's take the getObjectName block and concatenate the object's name with the string is not ready. We'll print the result to the console. Now, messages like cube is not ready and torus is not ready will be printed for the two objects standing still. Let's focus on the donut. Add the missing checkbox to it. Now, two objects are moving. And only the lazy cube is not ready to go to school because it forgot to grab a backpack. Moving on to the logical OR operator. This operator is used with two Boolean values to check if at least one of them is true. Suppose you are preparing to go to school again and want to bring fruits for lunch. It doesn't matter whether it's an apple, an orange, or both. Using the OR operator, you can check if you have at least one of these fruits. Add two more Boolean variables for all three objects. Let's name them apple and orange. For the sphere, check only the apple variable. For the cube, assign true to both variables. And for the donut, leave both variables as false. Change the variable names in the getters. Also change the operator on the gate block. Choose the OR operator. Start the game. Press the space key. The first two objects move forward because they have fruits. The sphere has an apple, and the cube has both an apple and an orange. But the donut's pockets are empty, so in the console, we see the message, donut is not ready again. Now, let's deal with the NOT operator. It is usually used to turn false into true or vice versa. This is useful for working with opposite values. For example, let's retrieve the onInit block again. Connect a setter to it. Specify a separate object in the object field, for example, the camera. Give the variable the name weekend and assign it the value false. Now we have a variable where we store information about weekends. And we go to school only on weekdays. And today is not a weekend. Using Boolean values, we can formulate the condition like this. You can go to school any day if it's not a weekend. In the gate block, change the operator to not equal. Remove one getter. In the remaining one, specify the camera object and the variable weekend. Connect a Boolean block to the second slot and switch it to true. Remove unnecessary blocks in the console output, leaving only one print block. Enter the string. Today is not a weekend. In short, here's what we've got. If today is not a weekend, it means we are going to school. If we run the game and press the space key, all three characters will move forward. If we switch the weekend variable to true, the next check will trigger the false channel because today is a weekend. All characters will stand still, and the console will output the message. Operators provide more possibilities when used together. Suppose you need to go to school only if today is not a weekend, and you've taken a shower, and you have an apple or an orange with you. Let's try checking if all these conditions are met. Switch the weekend variable to false again. After the first check for the weekend, let's connect another gate block. Choose the AND operator and check the truth of the variables shower and backpack. Connect the false channel to console output. Concatenate the object's name with the string is not ready. If this check is passed, we still need to check if we have fruit. Connect another gate block to the true channel. Choose the OR operator and check the truth of the variables apple and orange. Connect the false channel to console output. Concatenate the object's name with the string has no food. Start the game, press the space key. The sphere moves forward because it took a shower, has a backpack, and also has one of the fruits. In the console, we see messages that the cube and the donut are not ready for the school trip. This means they did not pass the second check. Let's check the shower and backpack variables for the cube and the donut. Now two objects are moving. And in the console, we see the message, donut has no food. Now let's check the weekend variable by checking the checkbox, indicating that it's a weekend. Now all objects are standing still, and in the console, we see a message that today is a weekend. Well then, now we can remove all the complexity we've created here. Let's talk about comparing numbers using Boolean values. Boolean values can be used to check numbers if this check implies a simple answer, yes or no. For example, imagine you work in an amusement park where one of the attractions has a restriction. Visitors with a height of at least 150 centimeters are allowed. When someone wants to ride, they provide their height, and you need to understand whether it's greater or less than the specified number. Let's create a global variable. Again for the camera. Let's call it height restriction. We will store the height restriction value in it using the integer block, assigning it a value of 150. Now, create an integer variable for each object, named height, and assign them different values. For the sphere, it's 155, for the cube, it's 150, and for the donut, it's 120. Now let's allow only those with a height of at least 150 centimeters on the attraction. Let's assemble a familiar scheme. When the space key is pressed, initiate a comparison of two variables using a gate block. We'll compare the variable height with the variable height restriction. For the height variable, leave the object field empty. But for the height restriction variable, we will refer to the camera. To determine if one number is greater than another, we need to use the greater than operator. So, if the height is greater than 150, the true channel will be activated, and the code chain connected to it will be executed. Let's connect another translate object block with a value of 0.2 on the y-axis to the true channel. Connect console output to the false channel, concatenating the object's name with the string small height. Start the game. Press the space key. The condition is met only by the sphere, so it gets on the attraction. In the console, we see messages that the cube and the donut are too short. We have a little discrepancy. The condition stated that everyone with a height of at least 150 is allowed on the attraction. And our cube happens to have a height of 150. Therefore, it would be logical to allow it as well. To fix the situation, we can choose the greater or equal. This would mean that the number 150 will also pass the check and return true. Now we can see how two characters have passed the check and are moving forward. The opposite operator is called the less than. It comes in handy if the attraction is intended only for small children. For example, only visitors with a height of up to 120 centimeters are allowed on it. Let's change the value of the height restriction variable to 120. A visitor with a height of 120 centimeters is still allowed to enter. All you need to do is change the comparison operator to less or equal. Now only the donut is moving. The others are standing still. To check two numbers for exact equality, use the equals operator. Let's model another classic situation. Imagine you've chosen a number for your friends, specifically the number 5. You made it easier for them by saying it's a number from 1 to 9, and your friends started guessing. First, let's create a variable mySecretNumber for the camera and assign it a value of 5. Now, pressing the space key will initiate the process of guessing the number. Create a variable named answer. Leave the object field empty. Connect a random integer block to the setter, specifying a range from 1 to 9. After generating the answer, we need to compare it with the secret number. In the gate block, choose the equals operator and compare the variable answer with the variable mySecretNumber. So, if the character guessed the number, let them move forward. But let's change the shift to 0.5 for better visibility. Immediately after the shift, print the expression in the console. Concatenate the character's name with the string winner. Also, connect the output to the false channel, where we'll concatenate the object's name with the space, dash, space, and the answer variable. Start the game, press the space key, and check the console. Sometimes, one of the characters will guess the number 5, taking a step forward, and the console will display the winner's name. Well, that's a brief overview of Boolean values. We can take a break at this point. In the next lesson, we will try to understand what arrays are. Bye for now.